Hi there. For these couple of lessons, I'm going to have myself on video so that you can see when I'm pointing to the screen. Make sure that you're paying attention to that. So if I point to the screen, maybe rewind and look at what I pointed to, because I'm not always going to be able to get there. Okay? Make sure that when you're doing your notes, do your notes, but then you're only doing the problems that's stated on this course calendar. So that is in Schoology in many, many, many places. I sent it to your parents. I sent it to you via a message in Schoology. It's on the updates in Schoology, and it is on the course page. So no excuses as far as not being able to find that. Okay, we're going to start talking about graphing quadratic equations. Okay, we learned about specific polynomials in Chapter 8, and one of them looked like this, and it is called a quadratic. And we have been working on factoring, and we've been working on breaking those apart. We know it's a quadratic because of that square, because there's an x term, and because there's a constant. Now, we don't always have a constant, and we don't always have an x term. But because that square is there, we know this is a quadratic. So we're going to work on graphing these. And there's a couple different things you need to know. The shape that each of these graphs is going to make is called a parabola. Okay, say that, parabola. So it's a para. Notice para is underlined because it's the same on both sides. Okay, it is U-shaped, and you can fold it in half, and you will find that they fold on top of each other. Okay, couple important things. So a lot of terminology in the beginning of our lessons. When we are looking at a parabola like x squared here, we are looking at the vertex. So the vertex, and we're going to always find the vertex when we're graphing. The vertex is either our maximum or our minimum, okay? This here on this graph, this red dot, is our minimum because it's the lowest point of that graph, okay? It's also the point where it shifts to go back up, making it so you can fold it in half, okay? A maximum would be like this. It would be the highest point. So it would be an upside down U, okay? Or kind of an N, but still. The label on the vertex of this graph is the minimum. It's the lowest point on the graph. So you could write lowest here too. And the coordinate on this specific graph was at 0, 0, okay? So 0, 0 is my coordinate. And remember, a couple times now I've said you could fold it in half. When I fold a piece of paper in half, right, it looks like a U shape, right? This looks like a U shape, and I fold it in half. Well, this side over here, the left side and the right side, are on top of each other, okay? Same thing with a parabola. You can fold this guy in half, and we would fold it in half on this blue line, and the green line on the left would be right on top of the green line on the right. This blue line on this graph, it's blue, would be called the axis of symmetry, or the line of symmetry, okay? I think in our homework assignments we call it axis, so let me write that word instead. And the axis of symmetry, there it is 0. It's always going to be the x, whatever the x value is in the vertex, our axis of symmetry is always going to come from that value. Okay, so what in the world does all this mean? Well, we need to know a couple other things. As we are looking at parabolas, they always have the same pattern when moving from point to point. So from moving from this vertex over to this point, it's up 1, right? It's plus 1. And then from going here to here, it is over 1. Oh, this was over 1, 2. And then it's up 1, 2, 3. So this is plus 3 from this point to this second point. And then going from this next point, it will be over 1 and up 1, 2, 3, 4, 5, plus 5. So this pattern continues on both sides. Here, I went over 1 and up 1. So this is plus 1. Over 1 and up 3. Over 1 and up 5. It happens on both sides. You'll notice both points are at exactly the same spot on both sides of the parabola. Okay? All very, very, very important things. So what do those words mean? If this pattern continues, what do you think the y-coordinates will increase by next? So they went up by 1, then they went up by 3, then they went up by 5. What would be the next one? Hopefully you said plus 7. Okay? So this pattern always goes up 1, up 3, up 5, up 7. My next one will be up 9, and so on by all of our odd numbers. And these are called building numbers. It's super important that you know this pattern. This pattern is essential for doing this. It always goes just 1 to the left or the right, but then it always goes up by our building numbers, okay? So here you can see the building numbers of these different parabolas. So this vertex, if this is my origin right here, my vertex is at 1, 2, 3. It's at 3 for my y and 0 for my x. So this is at 0, 3. It went over 0, up 3. Okay, from that point, from that bottom of this parabola, it went over 1, up 1, over 1, up 3, and then it would have gone over 1, up 5. Okay? For this equation, we have x plus 3 squared. That, if you look at the graph, we went over 3 and up 0. Okay? So you see the different positions that they're in based on the equation. So this is x squared plus 3. This is x plus 3, and that's squared. But the pattern continues. Over 1, up 1, over 1, up 3 on both sides. Okay? Then it would go over 1, up 5. So, understanding that pattern is important. Now let's learn how to find the vertex. Finding the vertex is literally just reading it off of this form. So this is called vertex form. Okay? H and K in this item here is the vertex. Okay? H and K is the vertex. So we have a number, and that number could be 1, times x minus h squared plus k. Okay? So here we have a number. What number is in front of here? Just an imaginary one. We have x minus 3 squared plus 1. So what's my h? My h is my 3. What's my k? 1, right? H is simply the number that is in there, but when we write it for our vertex, it's always the opposite. So my x value, oops, I circled the wrong one. My x value is always opposite of what's inside the parentheses that's being squared. So what's opposite of negative 3? 3. Okay? Your y value of your vertex is always the same. So what's that? That's 1. So my y value of my vertex is 1. Okay? Great. Moving down just a little bit. So if I look at, I'm not doing that, what my graph looks like, I would graph my vertex. I would graph my vertex. I think I'm going to show you how to do this instead of have it done. So my vertex was 3, 1. So let me move myself. There we go. Okay, so I'm going to go from 0, 0. I'm going to go over 3 and up 1, and that's my axis. That's my vertex. Okay? So now that I have my vertex, I can now graph from that point using my building numbers. From this point, I'm going to go over 1 to the right and up 1 and put it up. Then I'm going to go over 1 to the right and go up 1, 2, 3 and put it up. Okay? I'm not going to go up to 5 just because I don't want to move the screen around. Okay, so that is my right side. Now I need to do my left side. From the vertex, I go over 1, up 1. From the vertex, I go over 1, up 3. 1, 2, 3. Notice those are in the same position. The blue ones and the green ones are all in the same position. And now I connect my parabola to the best of my ability with a U and going through all my points. I kind of missed this green one, but do the best you can. Try not to make it look like a V. A V is a different kind of graph. Make it look like a U. Okay? What would be my axis of symmetry here? So what would be my axis of symmetry here? What x value did I go through? 3. Remember, my axis of symmetry is always going to be x equals, and it always comes from my specific x value of my vertex. So it's x equals 3. That's where I can fold it in half. Okay, next slide. So let's do a couple of these, all right? I know the notes are long, but that's so you have enough room to graph. So our first graph, I didn't want you to have that right away, so I'm going to erase that. Okay, remember, we find our vertex by opposite for my x value, so opposite, so that's going to be 1 because that's a negative 1. My y value is the same, so that's going to be 4. You don't need to draw those arrows. I'm just doing that for you to see that. My axis of symmetry is the same as my x value, so it's x equals 1. Okay, so now let's graph that. Over 1, up 4. Not the best graph for this, but it'll be all right. Over 1, up 4. So now from there, I'm going to go over 1 to the right, up 1, over 1 to the right, up 3. 1, 2, 3. All right? And do it again. Over 1 to the left and up 1, over 1 to the left and up 3. 1, 2, 3. And then you connect. Again, it's a U shape, so it needs to look like a U. And where's my axis of symmetry? Right there, which is x equals 1. Okay? I want you to try the next one on your own. I want you to look at the rules. How do I find my vertex? And then do your graph. So I'm going to pause while you do that. Okay, you should have got this for your answer. You should have got -2, -3 for your answer right here. Opposite of 2, same as -3. I go over 2 to the left, down 3. I can fold on -2, so that's my axis of symmetry, comes directly from my x value. And then I went over 1, whoops, I didn't want to move that, over 1, up 1, over 1, up 3, over 1, up 5 on both sides of my axis of symmetry, and this is my graph. Okay, I want you to look closely at example 3 before I switch over to it. So it says x squared minus 3, but there's nothing in the parentheses with the x. Like here, we got our x value because there's a 2 in the parentheses with our x. But on that one, there's nothing in the parentheses. So what's my x value going to be? I'm hoping that you said 0. Because what's really in here is either x minus 0 squared or x plus 0 squared, doesn't matter. But there is definitely no number in there. So then what's my vertex going to be? If that's x plus 0 squared, what's my y or my x value going to be? What's the opposite of 0? It doesn't have an opposite, so it's 0. Same as my y, so it's -3. Okay. What's my axis of symmetry going to be? Well, let's graph it. So I go over 0, down 3. This doesn't really work. 1, 2, 3. We'll estimate. Okay. Now, from there, we're going to go over 1, up 1. Then we're going to go over 1. How many did I go down? This is 1, this is 2, this is 3. So this is over 1, up 1, 2, 3. So right there. And you know what? I can just go over 1. I can draw that one. And, oops, I didn't go over far enough. Here's why. I got to do this one first. And I have to go over 1 from that at the same level as the blue one. And then I can draw my graph. What's my axis of symmetry here? Where am I going to fold this? X equals 0 because it also matches my x value. Awesome. Similarly, in example 4, in this example, we have something being added to the x squared term, right? We've got this -3 here being added to the x squared term. What do I have being added to my x squared plus 5? Where did it go? All right, what do I have added to x squared plus 5? I don't know where it went. I'll look for it. Oh, it's down further. Okay. So x squared plus 5, what's being added to that? Nothing, right? So it's going to be a 0. So what's my x value going to be here? -5, 0. What's my axis of symmetry? X equals -5. Fantastic. And then your graph should start out with your vertex at -5, 0, over 1, up 1, over 1, up 3, 1, 2, 3. That's enough. We'll just do that. Over 1, up 1, over 1, up 3, same level. Draw your U. And you're good to go. And that is how we graph a parabola. Make sure you look at what you're doing. A couple of those are bonuses on your worksheet.